Hi everyone, it's Michael Woods here. We're going to provide a quick overview of Secure Sockets Layer and then provide a demo of Wireshark analyzing SSL or TLS. Now let's jump into what you need to know beforehand, and that's TCP/IP protocol, which references the layers on the right hand side. And today I'll be using Mac OS and Wireshark to provide the demonstration. What will be covered, we're looking at SSL, TLS, a quick overview of the SSL certificate and the handshake process, and then jumping into the Wireshark demo of how that protocol works. Now it's worth noting there's lots of different terminology, but it typically refers to the same thing: SSL certificates, digital certificates, public key certificate, but it all commonly refers back to SSL. So Secure Sockets Layer SSL was developed back in the 1990s. It's got version 1 to 3. It's been deprecated and is now superseded by TLS or Transport Layer Security. It's recommended that you don't use this protocol any longer, but look, there might be some legacy systems that may require this. Therefore, interoperability is required. Transport Layer Security was introduced in 1999. It replaced SSL, and it's got version 1.0 to 1.3. However, it's known that there's some vulnerabilities with version 1.0, and it's not compliant with such regulations for the financial services industry as PCI DSS, which refers to sharing of card data between merchants. They both use public key infrastructure, or PKI, and that's how they secure communications between client and server. X509 is the standard that defines what's the information within certificates, and SSL and TLS allows for confidentiality through encryption and message integrity, authentication, non-repudiation through digital signatures and hashing. When a client requests a SSL certificate, you'll see the padlock or green bar up the top, and this is you typically see HTTPS. It certifies who owns the public key that's being shared with the SSL process, and then confirms the exchange of the public key in public, and then it uses this password to encrypt all the data between the browser and server so they can send the communication in a secure manner, and these passwords are not typically used. So if you look at Amazon, you can see that there's a green or padlock bar up here, and you can click on Show the Certificate, and it has all the details using X05 here. X509. In the certificate contents, you've got the organisation name, URL, state, country, date range that's available for the issuer, and the technical details. So you can see all this information here that's contained in the certificate information. Now, in a SSL or TLS handshake, so browser, so a client will request the server to be secure. The server sends back the certificate, public key, and authority information about the server. So this certificate information back to the client. They then share different random bits to create a private key between each other for the communication. They then both use that to decrypt the information that's sent between the communication channel, or the client and browser communication, and then they share the password to encrypt all the communication with that symmetric key cryptography. The quick overview of the handshake. We'll be focusing on the green area today. So first of all, the client sends across what protocol they'd like to use and the different types of ciphers that's available to use. The server then confirms which protocol version, sends over the certificate, and also sends through the cipher they'll be using for the communication. They create a session, a client session, so they can start communicating in that encrypted manner. They then confirm they're finished and they've got all the information, and then they start sending the data. We'll jump into a Wireshark demo now. It's worth noting there's some good filters that can be used in Wireshark. So if you type in ssl.handshake.type space ==1 or any of the codes below, you can pick out the different sections from below. So client hello equals 1 or server hello equals 2, which helps you pull out the different information within Wireshark, which has been quite helpful. So we've been capturing traffic previously from Amazon, so let's just have a look at that. So if you jump in, once you've captured your traffic in Wireshark and you type in the SSL, you can pull out the client hello, which is the first part of the handshake. Within this, if you right click and click on follow TLS stream, you can start seeing that full communication. But let's remove the SYNAC and handshake process. And if you type in and SSL, you just get the TLS or SSL information that's coming through. So in the client hello, you've got the handshake, you've got the random bit of information that I use to create that the public key and private key sharing information. You've got the cipher suites they can use, and they're using TLS, suggested using TLS version 1.2. The server then replies and says, yep, let's use TLS version 1.2. Here's the key, and this is the cipher suite or algorithm that I'd like to use. So RSA, asymmetric encryption with AES, symmetric hashing. The certificates then sent through and key exchange, and the server's finished saying hello. So there's the public key that's being shared and it's been signed, digital signature, using TLS version 1.2. The client then replies with their public key, and the message is started encrypting, and then they start creating the session. And here's the TLS session ticket, so they can start communicating, and then data is able to be sent in encrypted manner through SSL or TLS.